In this video, we'll look at even point moving averages and why they require an extra step to line them up with the original data. You'll also learn two centering methods and how to work backwards to find a missing value using a known centered moving average. Why do we center even point moving averages? Unlike odd point moving averages, like this example on the left, where the average naturally occurs on the middle data point. If I was to calculate the average of these three, it would fall in line with the Friday of week 1. If I was to calculate the average of these three, it would fall in line with the Friday of week 3. Even point moving averages don't land between two values. This example on the right, if I calculate a 4-point moving average here, the average will fall in between the second and third quarter of the first year. If I found the 4-point moving average of these four numbers, it would fall in between the third and fourth quarter of the second year. And that's a problem because we want the smooth data to line up directly with the original time intervals. We fix it by centering. Let's have a look at an example here about the number of cattle with a particular disease. We're going to calculate the 4-point moving average to begin with. If you're not sure how to calculate a moving average, whether that be a 3-point, 4-point, or a 5-point, please look at the previous video. But in a nutshell, we're going to take the first 4 points, 60, 67, 47, and 38 for the number of cattle. When I sum them together, it gives me 212. I divide that by 4 as I'm calculating a 4-point moving average, and it will give me a value of 53. The second 4-point moving average that falls in between the third and the fourth quarter of 2011 is 51. Now that we have all of the 4-point moving averages calculated, we can then go on to find the average of the two 4-point moving averages in order to center it. The reason that we do this is so that it falls in line with a given time period. As an example, if I were to find the average of these two 4-point moving averages, 53 and 51, the centered moving average would be the result of 53 plus 51 divided by 2, and that would give me a result of 52. We can now see the centered moving average falls directly in line with the third quarter of 2011. We repeat this process for the remaining pairs of 4-point moving averages. For example, the next one, 51 plus 47.5 divided by 2. Although this process is fairly easy, it's also extremely tedious. Having to calculate all the individual 4-point moving averages, and then the average of those averages to center them can be a time-consuming process. Then we have method 2. In method 2, we're going to skip the first part of calculating the 4-point moving averages. If I take you back to this example here with method 1, we can see that in order to achieve the 4-point moving average of 53, I needed the first 4 values from the data set. In order to achieve the 4-point moving average of 51, I needed the second 4 values of the data set. Altogether, there was 1, 2, 3, 4, 5 values which contributed to the centered 4-point moving average of 52. I'm going to use this knowledge to be able to skip the first step and jump straight into centering the 4-point moving average without calculating the moving averages beforehand. The way that we do this is to first of all find the 5 points that contribute to the moving average. Keep in mind that this only works for a 4-point moving average. If it was a 6-point centered moving average, there would be 7 points which contribute to it. If it was an 8-point centered moving average, there would be 9 points that contribute to it. Once we find our 5 points, which I'll highlight here, 1, 2, 3, 4, 5. Then going to halve the first and the last values. Once I've done that, I'm going to sum them all together or add them and then divide by 4. So even though I'm using 5 values here, I'm still finding a centered 4-point moving average. And so I'll need to divide by 4 at the end. It's a common mistake that students tend to make, is that they will then go and divide by 5 because they've used 5 values. So my working for this one will look like 4-point CMA would be equal to half times 60 plus 67 plus 47 plus 38 plus half times 52. And that's all going to be divided by 4. And it gives us our result, 52, which we'll notice is exactly the same as the centered 4-point moving average that fell in line with the third quarter of 2011 in the first example. However, it took a lot less time to reach that number. We can continue on in this fashion, and although it still is tedious and relatively time consuming, as we don't have the use of a CAS calculator to help us, we can skip the first step and jump straight to the final product of our centered 4-point moving average, which falls in line with a certain time period and helps with graphing, identifying trends and things like that. The 5 values that contribute to the second centered 4-point moving average are 67, 47, 38, 52, and 53. If I halve the value of 67 and 53, the first and the last values, add together 47, 38, and 52, then divide by 4, our answer will still be 49.25. And there we have the finished lists of the centered 4-point moving averages using method number 2, halving the first and the last points. Okay, now let's flip it. You're given a centered 4-point moving average and you need to find a missing original value. We need to find the value A. So we want to know how much expenditure is there in thousands of dollars based on the given 4-point centered moving averages. Some of the values are given around it, and we need to find the expenditure in December of 2019. Because it gives us the centered 4-point moving average, we essentially can set up an equation that will help us solve for the value of A. Using the steps given in the previous slide, we take the 5 values that contribute to the 4-point centered moving average that aligns with December of 2019. So we're going to focus on this 4-point centered moving average of 37.25. We know that 5 values contribute to that average. We also know that we need to halve the value of the first and the last number, add them all together, and divide by 4 to find the 4-point centered moving average. Let's write that down as an equation. Half of 40 plus 15 plus A plus 32 plus half of 38, all divided by 4, is equal to 37.25. There are 2 ways that you can solve this now. One, you could put this equation into a solve function using a CAS calculator like a Casio ClassPad, or alternatively, you could solve the equation using inverse operations. First step, I'll multiply both sides of the equation by 4. Then I'll simplify the left-hand side of the equation. So I'll look at what is half of 40 plus 15 plus 32 plus half of 38. I get A plus 86 is equal to 149. To find the value of A, I'll subtract 86 from both sides, and I can see that A is equal to 63. Let's recap. Even point moving averages must be centered. We can use either the average of 2 moving averages, or we can halve the first and the last values. Get ready to work in reverse if you're given a centered moving average and asked to find an original value. These types of questions show up regularly in tests and exams, so it's a must-know skill. Next, we'll jump into how to calculate all of this quickly and accurately using the Casio ClassPad.